So in our last video, we explored the concept of taking numbers and their exponents. So I wanted to explore a little bit deeper on taking negative exponents. Let's start simple. Let's start with 10 to the negative 1 power. We learned in our last video that this is the same thing as saying 0.1. And then there's actually another way to write this. We could say 1 divided by 10. And I can prove that to you using our handy-dandy calculator. So we can just type in 1 divided by 10. And what do we get? We get 0.1, so that means these are the same thing. And so this is just essentially the same way, or the same thing written 3 different ways. And I really like this third way because this fraction, this 1 over 10, we can compare it to 10 over 1. And 10 over 1 is just kind of the opposite of 1 over 10. And then, of course, 10 over 1 is just the same thing as saying 10. This dividing by 1 doesn't change anything. And there's actually one more thing we can do to 10 to not change the number, and that's take 10 to the power of 1, as we learned in our last video. That's the same thing as saying 10 as well. But if we take a second to examine these comparisons, these 3 on the left versus these 3 on the right, so I went ahead and boxed those in for us. Let's look at 10 over 1 versus 1 over 10. Well, if you look, they're kind of the opposites of each other. And then if you look, 10 over 1 is the same thing as saying 10 to the power of 1. So these are equal. This one and this one are equal. Well, if you look, 10 to the negative 1 is kind of like the opposite of 10 to the positive 1. And the same is kind of true depending on how you look at it of 10 versus 0.1. Because if you look at it, they're on opposite ends of our chart here. This 0.1 is on the opposite end of our 10. And then if you look at it, this decimal, this 10 to the negative 1, sort of moves it one place to the left versus this 10 to the positive 1, or 10 is this decimal moved one place to the right. So what we find is really no matter how we look at each one of these 3 numbers, they're sort of the opposites of these 3 numbers. And they're not exactly opposites. They're just kind of opposites depending on how you look at it. But what we call this is we call this an inverse. These are inverses to each other. So these 3 numbers are inverses to these 3 numbers. And of course, these 3 numbers on the left are all the same number, and these 3 numbers are on the right are all the same number. And so what is an inverse? Well, if we take a number to the negative 1 power, so if we take 10 and put it to the negative 1 power, that is taking the inverse. So we can actually even write that out for ourselves if we want to. Putting any number to the power of negative 1, so we can say to the negative 1 power, gives the inverse of that number. And this is true for all numbers in existence. And then the cool thing about inverses, if you look, this 1 over 10 is 10 to the negative 1. It means we're flipping the fraction. We take 10, which is 10 over 1, and we flip it. So taking an inverse flips the fraction, and all numbers in existence are fractions. Like even 10 is a fraction. It's just 10 over 1. And so looking at it this way, all numbers are fractions. So we can say, what's the inverse of 2? So 2 to the negative 1. Well, 2 is the same thing as saying 2 over 1. So the inverse of 2 to the negative 1, is the same thing as saying 1 over 2. We're just flipping the fraction. This is also true for 5. If I were to say, take the inverse of 5. So 5 to the negative 1. Well, that's the same thing as saying 1 over 5, because 5 over 1 is the fraction version of 5. And so if this is true for any number, we can write this out as x to the negative 1. The inverse of x to the negative 1, is the same thing as saying just 1 over x. And then just insert any number for x. And so that might make sense, this taking it to the negative 1, but what about other exponents? What about other negative exponents, I should say? So what if we took 10 to the negative 3rd power this time? We learned in our last video that that's the same thing as saying 0.001. And there's another way to write that. We can put it as 1 divided by 1,000. And I can prove that to you real quick. We could pull out our handy-dandy calculator. We could say, what's 1 divided by 1,000? And what do we get? We get 0.001, which is the same number. And then we can look at that, and we could say, well, that's the inverse of 1,000 over 1, which is just 1,000, right? And then we learned in our last video that 1,000, another way to write that, is just 10 to the 3rd. And that's what I love about math, is that it always works. So we can even look, 1 over 1,000. Well, 1,000 is the same thing as saying 10 to the 3rd. So we could say that this is the same thing as saying 1 over 10 to the 3rd. And that makes sense, Because if we take 10 to the third divided by 1, we turn it into a fraction without changing the number, and these are clearly inverses. In fact, we can even write that out for ourselves, that these are inverses to each other. And then you might notice that, well, this is the same thing as the original number, just flipped and on bottom. And that's correct too, and actually that was happening before. If you look at it, 2 to the negative 1 is 1 over 2, which is the same thing as saying 1 over 2 to the positive 1. So we just take this number, put it on bottom, and make the exponent positive. And so that's what happened here. We take this negative 1 and put it on bottom, so 1 over 5 to the first power, and make the exponent positive. And this is kind of a rule. This equals x to the negative 1 is 1 over x to the positive 1, since that doesn't change the value. X to the positive 1 is the same thing as saying just x. And so you might be asking yourself, well, why is that happening? Well, we can actually break that down very simply. What if we rewrote this saying take the inverse? What if we rewrote this as a problem saying take the inverse, I should say. So what if we wrote 10 to the positive third times negative 1, where this whole thing, this 3 times negative 1, this whole thing is the inverse. Well, then we are taking it to the negative 1 power, which means take the inverse of 10 to the third, which would be 1 over 10 to the third. So this is just 5 ways to write the exact same thing. And in fact, I can even show you a 6th way where these are all the same thing. This 10 to the negative third is opposite to 10 to the positive third on our chart, both in the chart that we drew and in the chart they give you in your formula chart. And actually, that's true for all of these. These are all inverses. The opposites to each other on our chart are inverses. And so hopefully this simplifies inverses enough to make it where we could solve any problem. We'll rewrite x to the negative 6, let's say. What is that? Well, we can rewrite this in the same way we did over here as x to the positive 6 times negative 1. And then, of course, that just means take x to the positive 6 and put it on bottom, which, of course, we could, if we get good enough at this, we can recognize we don't even need this. We could just skip the middleman. But that's basically it. That's inverses in a nutshell.